This is a journey to Venus. The spacecraft sails through the vast expanse of the cosmos, heading toward the Sun. It eventually arrives at the airborne colony, floating high above Venus's cloud decks. There, the sky unfolds in magnificent shades of golden light. Every 1 year and 7 months, Earth reaches an ideal launch window for Venus-bound missions. In comparison, launch windows to Mars occur only once every 2 years and 2 months. Now, the fusion-powered Venus transport, carrying 87 passengers, is preparing for departure. The ship is expected to reach the floating city above Venus's clouds in 1 month. The journey officially begins at this moment. All systems are nominal, and every metric is performing within optimal range. The spacecraft lifts away from Earth's surface, leaving behind its blue sky. It heads toward Venus, a world shrouded in layers of yellow clouds. Once it reaches orbit, the second-stage fusion propulsion system ignites, providing a continuous stream of power for the deep space cruise ahead. The spacecraft steadily accelerates, generating thrust equal to 5% of Earth's gravity. This mild artificial gravity prevents objects from floating freely, causing them to drift downward at just 1/20th the speed they would fall on Earth. To move around more easily, passengers wear magnetic boots inside the cabin. During sleep, they secure themselves with straps to keep from drifting away from their beds. Many passengers carry small gravity keepsakes, such as rings or snacks. They watch these items fall slowly in microgravity, imagining how they will behave under Venus's stronger gravitational pull. Meanwhile, the spacecraft performs a slow roll maneuver known as a barbecue roll, evenly distributing the sun's heat across its hull. Thermal sensors determine that the ship rotates between 1 and 3 times per hour, increasing gradually as it approaches Venus. The viewing windows are equipped with protective solar filters, allowing passengers to safely gaze into deep space. Earth dwindles behind them, becoming a distant, blue marble. While ahead, the sun now dominates much of the visible sky. The spacecraft crosses the inner solar system at a steady pace. Midway through the journey, on day 15, the ship will execute a 180-degree rotation and fire its engines to begin deceleration. Through the windows, passengers can see Mercury glimmering in the star-filled void, a bright point of light against the darkness. Venus, however, remains concealed within the sun's intense brilliance. At this stage, communication with Earth becomes increasingly difficult. High-energy particles from the sun disrupt radio signals, causing intermittent dropouts. The communications array must precisely adjust its pointing direction, relying on automated retransmission systems to keep contact with Earth as stable as possible. Many passengers drift into dreams in the low-gravity environment. In microgravity, they feel as if they are flying, effortlessly crossing vast distances with a single movement. Their dreams appear clearer and more vivid than they do on Earth. Some dream of returning home, once again feeling the familiar weight of Earth's gravity. Under the mild 5% gravity, the human body undergoes subtle physiological changes. Fluid redistribution alters taste perception, making salty flavors noticeably weaker. To adjust, passengers experiment with different seasonings from the onboard galley, exchanging recipes and culinary tricks. A Tagara-style spice blend becomes surprisingly popular. From the start of the journey, the medical team closely monitors everyone's health. With only 1/12 of Earth's gravitational load, bones experience far less stress. The cardiovascular system works less intensely. Muscle tension decreases, and both circulation and bodily fluid distribution shift accordingly. The sense of body position is also affected by prolonged weightlessness. To maintain physical fitness, every passenger must complete 3 hours of specialized exercise daily, along with routine health checks. These medical data help scientists predict the readaptation process awaiting passengers. Once they arrive at the Venusian sky colony, where gravity reaches nearly 89% of Earth's, the 87 passengers have now traveled 1/3 of the way. During leisure hours, they don virtual reality headsets in their private cabins, immersing themselves in personalized entertainment. They share stories of favorite foods from home and recount their past adventures across the solar system. from lunar bases to Earth orbiting stations, and even the red dunes of Mars. Some scientists devote themselves fully to research, studying genetically enhanced space, crops, and optimizing seed growth in microgravity. Engineers work on expansion plans for the Venus colony, designing larger biodome platforms and developing smart drones, capable of dispersing targeted materials within Venus's clouds, to shape airflow and reduce dangerous turbulence near the colony. As the spacecraft nears the Sun, the navigation computer continuously adjusts its trajectory. It must balance two opposing forces: the Sun's powerful gravitational pull, drawing the ship inward, and solar radiation pressure, pushing gently outward. These factors were built into the mission design, along with Venus's own orbital behavior. Venus completes one orbit around the Sun in just 225 Earth days, yet it rotates once every 243 Earth days. This means that a Venusian day is longer than a Venusian year. Furthermore, Venus's atmosphere rotates far faster than its surface, circling the planet once every 4 Earth days. As a result, residents of the floating colony will experience 48 hours of daylight followed by 48 hours of night, watching the sun rise in the west and set slowly in the east. Inside the spacecraft, artificial lighting simulates Earth's 24-hour day-night cycle, helping passengers maintain stable circadian rhythms. From the observation dome, passengers watch real-time projections of Venus's shifting atmosphere, the ship's trajectory updates across holographic displays, and a virtual astronomy guide helps them identify celestial objects. They can even link to the main telescope to explore deep space, or view live images sent from satellites across the solar system. Some passengers gather to play strategic interstellar trade simulations, managing cargo across virtual planetary routes. Their journey is halfway complete, and the critical flip and burn maneuver is approaching. On day 15, all loose objects are secured. Main engines shut down, and the attitude thrusters begin a slow rotation, bringing the ship into a temporary zero-gravity state for 30 minutes. Passengers join together for the traditional flip day group meal, eating space foods while suspended in new orientations, feeling as though they are hanging upside down inside the cabin. Outside, Earth shrinks into a sharp point of light, while Venus grows steadily larger, a slender white crescent against the darkness. The rotation alignment completes. The engines ignite once more. The ship begins, reverse thrusting, entering the official deceleration phase. Earth's signal delay now reaches 1.1 minutes one way. When the flip maneuver ends, the ship's artificial gravity returns to 5% of Earth's, pulling toward the engine-facing direction. The entire vessel decelerates backward toward Venus's orbit. First-time Venus travelers explore a virtual recreation of the floating colony, while veteran crew members explain the realities of high-altitude life, including native skyfish and the mythical Halo Gate, a shimmering ring-like phenomenon believed to be linked to ancient Venusian legends. Upon arrival, some passengers will join the community of triplanet explorers, those who have lived on Earth, the Moon, and Mars. One doctor on board once served with the Mars Medical Corps, and now studies how future generations born in Venusian cloud settlements may adapt biologically over time. In the dining lounge, young engineers laugh and share stories of their construction projects on Earth, the Moon, and Mars, wondering whether Venus's floating platforms will become their greatest engineering challenge yet. Their destination consists of interconnected megastructures, hovering 55 kilometers above Venus's scorching surface. At this altitude, pressure and temperature resemble Earth's, and thick cloud layers shield residents from harsh radiation. Gravity is 89% of Earth's, far more suitable for long-term human health than Mars's 38%. Venus's dense carbon dioxide atmosphere is 65 times heavier than Earth's. In such an environment, breathable air rich in nitrogen and oxygen acts as a natural lifting gas, enabling the construction of massive floating platforms. To maintain sufficient buoyancy, additional hydrogen-filled chambers are used. The colony's structure is layered. Hydrogen flotation tanks above, human living quarters below, The current population of the Venus cloud colony is 1,872 residents. Passengers peer through the windows as Venus appears as a thin, brilliant crescent. Sunlight paints its bright cloud tops, and the day-night boundary drifts slowly across the sphere. As the ship draws nearer to the sun, thermal management becomes critical. The VP7 cooling system operates at full capacity, handling both the heat from the fusion drive and the intensifying solar radiation. Solar radiation increases inversely with the square of the distance, having the distance quadruples the radiation. At Venus's orbit, sunlight is 1.9 times stronger than at Earth. To withstand this, the spacecraft is coated with multiple reflective layers and advanced thermal protection materials. As it approaches Venus, the outer hull reveals a lithium-based, acid-resistant layer, designed to withstand microscopic sulfuric acid droplets within the clouds. The ship, Venus Planetcraft 7, is a hybrid aerospace vessel, combining spacecraft engineering with aerodynamic design. It features deployable control surfaces and precision docking thrusters for stable passage through Venus's dense atmosphere. It also serves as a mobile research platform for atmospheric exploration missions. According to schedule, it will soon rendezvous with the floating colony's docking facility. As the journey enters its final phase, the ship performs orbital insertion burns while maintaining reverse orientation. Passengers move into the internal safety module, and all viewing windows seal shut to protect the cabin from intense atmospheric compression heating. Once the main engines cut off, attitude thrusters rotate the ship 180 degrees, restoring forward-facing flight. A final braking burn brings the spacecraft into stable Venus orbit. It then begins its descent into the upper atmosphere. Deployable wings and stabilization structures unfold, allowing precise control in Venus's dense air. Over the next 2 days, the ship will adjust altitude and velocity to safely dock with the colony. When the seatbelt lights switch off, passengers have officially arrived at Venus. The windows open again to reveal a world of swirling yellows and oranges. Through the thick, sulfuric clouds, they occasionally glimpse fast-moving atmospheric bands, a breathtaking spectacle shaped by super-rotating winds. At the colony's altitude, the spacecraft's shadow appears on the clouds below, surrounded by a radiant halo, an optical phenomenon created as sunlight interacts with sulfuric haze. After 1 month in space, under 5% gravity, their bodies will need days to adjust to Venus's 89% gravity. The medical team conducts final health checks to ensure everyone transitions safely. Through breaks in the clouds, the colony's vast structures slowly come into view. Other spacecraft glide through the skies, conducting logistics and research operations. Tall energy towers rise from the platforms, covered in solar collectors strong enough to harvest Venus's intensified sunlight. Enclosed turbines capture the planet's rapid winds, working alongside fusion reactors to power the entire aerial metropolis. As they approach, the colony emerges, a network of interlinked floating megaplatforms and functional districts. The ship begins its final approach. It syncs with the colony's high-altitude satellite network, which uses specialized frequency bands to penetrate Venus's dense atmosphere. The spacecraft carefully matches the colony's heading and drift, approaching at a skim-orbit velocity to minimize turbulence-related risks. The docking platform, supported by hydrogen tanks above and equipped with adjustable thrusters below, stabilizes itself to counter the ship's momentum. In a precise and delicate sequence, the spacecraft finally makes contact. The docking clamps extend and lock into place. The journey of the 87 passengers has come to an end. They step forward as the newest residents of the floating Venusian metropolis, joining the 1,872 settlers already living among the clouds. Through the colony's grand observation windows, they watch Venus's sunset spread across the sky, casting brilliant colors through the golden haze. Below the thick cloud ocean, the planet's true surface remains hidden in eternal mist, waiting for humanity's future exploration. Thank you for journeying across the cosmos with Interstellar Whispers today. If these mysteries stirred something inside you, don't forget to like, subscribe, and share this video so more explorers can join our voyage. Your support is the energy that keeps Interstellar Whispers unlocking new secrets of the universe. Until next time, see you among the stars.